Hello, in this video we are going to learn how to find the components of a vector. It is very important to find the components of a vector because in statics, in electromagnetics, in physics, in many courses you need to know the components of vectors to can do some calculations. So for every physics problem and mechanics problems, you first should determine the system of references. You're solving your uh, problem in which frame of references. Assume that we have this frame of references and we have vector A and we would like to find the components of vector A along x-axis and y-axis. For this, you should draw two perpendicular lines. The first one will hit the x-axis and it would be x component, and the second one would be the y component. So the incident point, the distance of incident point of that perpendicular line to the origin will give you the y component. So then you can write vector A equals to ax I hat plus ay j hat. This represents the equation. This is the address of tip point, the tip of vector A in the space. This is two-dimensional space here. So ax I hat plus ay j hat. Ax is a scalar, ay is a scalar. It means they are just magnitude. But what is I hat and j hat? I hat and j hats, they are vectors. But the vectors that when you multiply it to a number, it doesn't change the magnitude of that number. It just gives directions to that magnitude. So we call them unit vectors. For example, I hat is a unit vector along x-axis. It shows that you have one step along positive x-axis, and the same thing is y j hat, that is a unit vector along y-axis. So when you want to address the tip of vector A in the space, you would say, okay, 5 unit to the right, so that would be 5 I hat. I'm translating it from math language to human language. You can write vector A like that, 5 units I hat. So 5 I hat means 5 unit toward positive x-axis plus 4 unit toward positive y-axis. If you want to get from point O to the tip of vector A, you can walk 5 unit along x-axis and then 4 unit along positive y-axis. There is another way. When you have the vector, the magnitude of vector, and you want to find the components, again you draw two perpendicular lines, but this time the angle that this vector makes with the x-axis or y-axis or positive or negative x and y-axis is given. So here the data that you have is alpha and the magnitude of vector. 10 newtons, for example, 30, 45 degrees from x-axis. How to find the component of this type of vectors? So as you can see, we have a right triangle here. So whenever you have a right triangle in your problem, you can take the advantage of trigonometric functions because they make it more easy. So x component is a cosine alpha and y component is a sine alpha. No worries. I will explain why it is sine, why it is cosine. So for ax you can just substitute a cosine alpha, and for y you can substitute a sine alpha. But why cosine and sine? This is a question of many students. Sine alpha, you know, according to the trigonometric relations and trigonometric ratios, is defined, this is a definition, opposite over hypotenuse. The side that is opposite to angle alpha, that is here, and it is equivalent to ay. Opposite side over hypotenuse. Hypotenuse is the largest side of a triangle, right triangle. So vector A. Opposite over hypotenuse. So sine alpha equals to AY over A, the values of hypotenuse A and opposite side AY. And when I isolate and solve this equation by multiplying both sides to vector A, I will get AY equals to A sine alpha, which is why I'm writing the opposite side, or the y component of this vector is A sine alpha. I explain these things in my trigonometric videos, trigonometric functions videos, that you can watch it in my channel. Cosine alpha equals to adjacent over hypotenuse. This is again the definition of cosine, and here the adjacent side is ax. You see, this is the adjacent side to angle alpha. If I plug ax and a here and solve it for ax, I will have a cosine alpha. So whenever you have the size of a vector and the angle of a vector, construct a triangle, and then determine the adjacent and opposite sides, and use these trigonometric ratios to find the, the values. You know, when you get more experienced, you don't need to write everything there. You directly say that, okay, opposite side is always a sine alpha and adjacent side is a cosine alpha. Please don't make this mistake to say cosine, the x component is always cosine. No, because you're not sure that this angle alpha is given. Maybe they give you the angle between vector A and y-axis, then the sine and cosine will switch. So the most safe way to calculate this is to build a actually you can highlight your triangle and then calculate the components based on that triangle. Now let's solve an example with some given data and numbers. Okay, there is a force of A acting on the center of this. It can be an object at the center of this system of coordinates, 5.38 Newton, that is making the angle of 68.2 with a negative x-axis. What is the components of this vector? You can pause the video here and try it by yourself. Okay, so similarly, we draw two perpendicular lines. We consider our triangle is this. That makes sense. So the adjacent, you always use the cosine, correct? So you should say that is 5.38 the magnitude of vector times the cosine of angle. And you can guess what would be the opposite. Same thing, but with sine. And then you can write the component of vectors, and that would be 5.38 cosine 68.2 I hat. It's very important to write these unit vectors, plus 5.38 sine 68.2 degrees j hat. That gives you a equals to negative 2 I hat plus 5 j hat. It is very important that you put this negative here. Actually, I had to put this here as well, I forgot, but you can put it at the end. Negative 2 shows that you have to move 2 units to the left of x-axis, because it is toward negative x-axis, the component. If I draw a vector here for you, you can see that this vector would be like that, and it is added to another vector that is 5 units along j-axis. So 5 units up. Do you remember? This is a parallelogram method, the big diagonal. So you are actually adding 2 vectors. This is first vector along x-axis, and this one is the second vector along y-axis, that you can add them to each other and build vector A. For 3 dimensions, that would be the same. I will make a video for that as well. and I hope you learned it very well. Please look for examples I solve in my channel to practice more.